Hi class, welcome and again to another session on biomaterials. We have discussed fixation devices in the previous video where we spoke about pins, bone pins, or to be precise, then bone wires and bone screws. So moving on, we shall discuss bone plates today, which is also another type of fixation device. So bone plates are available in a variety of shapes and are often used to fixate a fractured bone fragment. So they are available with a varying range of mechanical properties, starting from a really rigid plate to a relatively flexible plate that facilitates mechanical loading of the joint. So depending upon the site of insertion, the bone plate, you'd either choose rigid or flexible bone plate. So if the fracture is near the joint, then you'd probably require a flexible bone plate which would assist in mechanical movement of the limb, right? If it is like in the shaft of the bone, you would want a rigid plate that supports the bones, that firmly supports the bone and assists in its growth. So the rigidity of the bone plate depends upon the material that is being used for manufacturing, as well as the cross sectional area of the plate. So if the plate is if the plate is very thick, then it wouldn't it cannot, you can't have really thick plates because that would not be ideal for biomedical implantation. At the same time, you cannot have a really fragile flimsy plate because that means that would result in the failure of the implant once the joint starts to load bear, right? So ideally you have to have a there has to be an ideal or an optimal cross sectional area which would decide the rigidity of the plate. Again, a very stiff plate shields the bone from physiological loading. So whatever load the bone is supposed to undergo, that load is being shielded by the plate because it's very rigid. It's taking over the function of the bone. So the bone is just lying there ideal, not doing the work that it is supposed to do, and that would affect the surface of the bone, or that would affect the overall health of the bone. Also, if the plate is very closely fixed, if it is rigidly plastered with the bone, then that can affect blood circulation on the surface of the bone, and which can again affect the quality of the bone, right, the health of the bone. Therefore, we require the optimal choice would be a plate with minimal contact and the one that is flexible. So basically, titanium plates are very popular because it satisfies these two criteria. Again, plate is most resistant in tension. Therefore, in fracture of long bones, the plate is placed alongside the bone which is typically loaded in tension. So the side of the bone that endures the tension is where the bone plate will be fixated. So excellent apposition of the bone fragment as well as developing adequate compression between them is critical in maintaining the stability of the fixation and preventing the plate from repetitive bending and fatigue failure. So you have to make sure that the bone fragments are totally supported by the plate, as well as there is adequate compression between them, because that would ultimately result in optimal load bearing in your implant, which in turn would increase the life. So if there is irregular load bearing in the implant, or if the implant is subjected to bending, then that would result in implant failure ultimately, right? Interfragmentary compression will create friction on the fracture surface, and that would increase the resistance to torsional load. So if there is too less compression between the fragments, then that would increase the torsional load, and if there is too much of compression, then that can lead to microfracture and also necrosis of bone tissues, because the bone will because it will collapse the vesicular channel. So there won't be much like the cells of the bone would die because of too much compression. Now, bone plates are often contoured in order to fixate irregular bones. So you often have to bend the bone plates to a certain extent to fixate irregular bones. So irregular bones, you have quite a few examples of irregular bones. The vertebral column is made up of irregular bones. Again, you have your tarsals, metatarsals, your carpals and metacarpals, which are irregular bone, right? Though you cannot define them in a particular shape. So in order to fixate fracture of these bones, you have to have a bone plate that can be contoured slightly. However, too much of bending of the plate is also not advisable because that would decrease the service life of it, and which is one of the reasons for implant failure. Screw loosening is also another reason for implant failure, because if you see, bone plates cannot be glued to the bone, right? They need to be screwed inside the bone, and you have often the screws loosen over a period of time, either because of wear or because of physiological reasons. So that would also result in implant failure. Now the figure towards your left has got a few bone plates. So this is how a bone plate looks like. The holes in between the plate is where the screws are inserted and fixated, and these screws are fixated to the bone. So the figure towards the right has got a few examples. This is an example where bone plate is inserted on a fractured long bone and in order to fixate it. So this looks like radius to me, but correct me if I'm wrong. So this is like yes, it is. No, it is humerus, I think, because I can see the rib cage here. So this is inserted in humerus, and then the plate is fixated in the shaft of humerus with the help of the screws. I hope you had a very fruitful session learning about bone plates with me. I shall see you again in another video. I hope you take care till then.